Hello everyone, welcome to the presentation. My name is Paramjeet Sambi, also nickname is Lucky. The equipment manager at Castool. I can be contacted through sales@castool.com. So here we go. So first off, we'll go over the various ovens that we make, the different models available. So we build the super ovens, we build the triple cell ovens, single cell ovens, container dummy block, manual ovens, and all kind of custom ovens. Super ovens are basically four-sided heating ovens. The nomenclature is TCX or CX. X stands for four-sided heating. Triple cell ovens are labeled as TRCs. So you have TRC 40, 50, 60. And we can also do super ovens and for single cell ovens. So, if there's a space constraint, you could buy single cell ovens from us. And we could also do dummy block and mandrel ovens. Mandrel ovens require special cradles, but we can build them. So here we're showing you the super ovens where you have four-sided heating. So you have basically this being one zone and this is the other zone. So these super ovens are basically best used if you're using on big dies because they have a lot of surface area. So we can make best use of the surface area and heat up the die quickly, safely to the target temperature. You have the triple cell ovens. What it is you have the two-sided heating and you have multiple cells. So these are good for smaller dies where the dies are not very thick, and so you can just heat them from the two sides and get them to a target temperature. We also do container heating oven. This is showing you a container basically going into oven. This oven liner size is around 70 by 70 by 70. These are the standard oven sizes available. You have the TCX 100, 200, and then you have the triple 40, 50, and 60s. And obviously we can do all kind of custom ovens. The sizing limitation that we posted here is, we prefer leaving about 2 inches per side of clearance. So when you're loading the die and loading the die, you're not hitting the sides kind of thing. Sometimes you can get away with about 1 inch clearance per side, but we prefer to have at least 2 inches. So we're going to get into the master controller now on why we recommended going with the master controller setup rather than a standalone oven. Basically what it is it's a centralized user-friendly interface. So you can get everything done from one point basically of interface. You can control all your lids. It's centralized lid control. You can open and close your lids and have a better control. You can do a better visual control, and it's got really advanced data logging features, so you can track all kinds of things, all the events, your trends and everything, even to a database. You can run reports from them. You can locate it away from the die handling area. Basically, if you've got a crane right on top of the ovens, putting the screen right on top of the oven is sometimes not the most ideal spot. So people do end up damaging the screens if they're mounted right on top of the ovens. We recommend going with the master controller. This way you can mount the screen maybe at the press right beside the other screens that the operator has access to. So operator just has to look at, he doesn't have to go to multiple screens and to see what is the cycle status, if this, how long the die is going to be in there and stuff like that. You can track energy, how much energy you're consuming centrally. You have less spare parts to carry, and it's the more economical approach. Here's a setup we did at Sapa, China. You can see here you have one pedestal. Basically, you have a screen, you have the anti-tie down buttons, and you have multiple cells. This is a setup we did at Sapa, Nanjing. You can see the multiple cells, and they're done in a different color. This is our standard color now, RAL7035. So yeah, they could be configured. They don't have to be in a straight line. You could put them as as the floor space is available. Master controller. So what we're recommending is going with the Castool default master controller setup, running the IWS or Indosoft Web Studio software. It's basically SCADA software. You can also, if somebody prefers to go with Allen Bradley or Siemens, we can offer that as well. The basic controls that we have already done are, you can do Allen Bradley, Siemens, Mitsubishi, and Omron. All the controls are done with Ethernet communication. And so you can network them onto your plant network, grab data, or you have a SCADA system running, you can grab information from our ovens. They are not black boxes. You can communicate to them and we'll work with you to communicate. Yeah, we can do various languages. You could do, all kinds of languages. Sometimes fonts are an issue, but we will work with the customer to make the interface as user-friendly as possible. With CE declaration, we do have to do the native language, and we do comply with that. We offer the screen interface that way, even the documentation, the manuals and stuff, we can do in the native languages. So the Castool preferred oven master controller setup, this is showing you a 6-cell setup. So what we're saying is let's say we're going with our standard most economical approach. You would put PLCs like a Micrologix 1100 or a 71200, a Siemens one in each cell, and then you'll have a centralized screen. So there's no PLC inside, and you have one screen communicating to all the ovens. And obviously this would be an industrial computer running SQL Express database, so you can save all the events, transactions to a centralized database, and you can run reports and stuff. And it's the most cost-effective approach. So here we're showing you basically how it is connected. Everything is through Ethernet connection. So you have the PLCs connecting, multiple PLCs, oven 1, oven 2, oven 3. One PLC can run 2 cells kind of thing. And then you have a database connected. The database could be remotely situated, or you could run it right on the same computer as what's running the IWS software. So this is a typical electrical panel where you have a PLC rack. This could be Allen Bradley or Siemens. You have your high limit controllers on top right hand side. You have your RJ45 ports for Ethernet for networking, and just the standard stuff. This is the setup I'm showing you is with Allen Bradley. Basically, if somebody says no, we don't want IWS, we want to go with Allen Bradley. Yes, the cost is a little bit higher, but we can do it, and we do it. So here we're showing you ovens. Basically, what we recommend if we're going with Allen Bradley, so each cell will have remote I/O. So remote I/O for cell oven 1, 2, 3. And then everything connects to a centralized PLC. So you'll have a CompactLogix PLC running in the master controller connecting to the touchscreen. So this is where you would be running a FactoryTalk runtime software. We could also put the Allen Bradley Panel B Plus screens as well, but that is where you have to specify at the time of order, so we can build the right system for you. So here I'm showing you the remote IOs on the left hand side. So they would be per cell, and then you have a centralized PLC located in the master controller, and you have the HMI runtime software running, showing you multiple cells running. And then you have the transaction manager, which is optional. So what it is you would save the data coming from the PLCs, from the remote IOs, let's say the temperatures, when the cycle was started, when it stopped, when it was unloaded, to a database. Here I'm showing you a Siemens oven master controller setup, where you would have the same remote IO on each one of these in these ovens, and then you will have a master controller running S7314 PLC with a touchscreen, which could be Siemens or an industrial computer. So why we use IWS, the software that Castool recommends as default. So it has built-in drivers to communicate to various PLCs. So you're not really logged down to a certain brand, like okay, you can only talk to Allen Bradley or Siemens, or so it has is multitude of different communication drivers. It's the most economical approach. It's very powerful, and it doesn't slow down the network. So there's an option available, so you could access the whole software, the running software, let's say through a mobile, like a tablet, or like with a web interface, running a thin client. So you don't need a heavy-duty computer. And so only one software is needed. So you don't need two softwares, like one for communicating to PLCs. The other one is like a transaction manager where you're saving data to a SQL database or something like that. So it's an all-in-one approach. And like I said, it's the most cost-effective way to get the master controller set up and get all the features. We're going to talk about the heating cycle now. The oven should already be hot. We're saying, run the oven for at least 1.5 hours, and let the insulation, everything be hot at that temperature before you actually put a die from room temperature into the cavity and run a heating cycle. Our approach is a recipe-based approach for figuring out the cycle times. You also input the die number and copy number, so you can track what die copy is in what cell. And we can also pull recipes from a database. Let's say you already have a database on, the target temperature should be different for each die copy. We can grab that information and work with the customer's database to run heating cycles. So basically the approaches for heating cycle, we use the diameter and thickness to figure out our cycle times. The target tolerance by default that we quote is plus or minus 2% of the target temperature. The cycle length is directly proportional to the precision required. Basically what we're saying is the tighter the tolerance you want for the target temperature, the more you have to soak. I'll cover that in my next slide. So here I'm showing you a heating cycle. So here's the heating cycle, and here is basically the soaking time here. This is where we shut the heat and it's soaking. So all the temperatures in the die are getting within the tolerance. This line here you see is where you're within tolerance of plus or minus 2%. So, but the longer you keep the die in the oven, the tighter it gets. Okay. Recipes. So since we're using a surface area to calculate the cycle times, what we found is the surface area sometimes varies too much between different. Even the diameter and thickness would be the same, but the surface area on a die could be way different. So that affects our heating curve. So that's why we came out with the recipe-based approach. So what it is we allow the customer to make specific recipes where you could figure out different times. Let's say this is the quad heating zone where all four-sided are heating. This is two-sided heating, and then you have the soaking time. All of this could be made into a recipe, so you get tighter tolerance at the end of the cycle. So there's no overshoot and stuff like that. So here you have the recipes example. You have the diameter, thickness, soaking time, and stuff like that. So you could make as many recipes as you want. You can label them as you want. You could have the British standard or the metric approach, Fahrenheit or Celsius to or inches or millimeters, stuff like that. So it's totally customizable. Starting a heating cycle. So basically what you do is you would go to the main status screen, you would press the setup button, and then you go and put your die number, copy number, you would select a recipe, and then you press start, and that's it. You start heating the die and you will get a time to temp countdown here. The screen goes yellow and you will get a countdown to the target temperature. So once the target temperature is achieved, the clock starts counting up. Another thing which is very important is using a deferred heating cycle. Basically, it allows you to set up a cycle where you can shut down on the weekend and turn on the oven automatically and be at temperature at the start of the shift. So you're not wasting energy or oxidizing your die. To set up the deferred heating cycle, basically you would go to the setup screen and you would set up your weekday, hour, minute, and you press defer on. And after you turn the defer cycle on, the cell will become this green color and it will tell you the defer cycle is on. Here you would see on the main status page, it will tell you that, okay, defer cycle is set up and it's going to turn on at 10:48 a.m. on Tuesday. Defer cycle setup. So basically what we're showing you here is normally the oven would be hot, let's say on Friday at the end of the shift, you would load a room temperature die and you would set up your cycle from the screen. So now originally the cell will be hot and die would be cold, but after you leave the die in the oven for 6 hours, so the oven is basically, the cell is cooling down and the die is still going to soak. So after 6 hours or so, the die and the cell are at the same temperature. This is very important for us. Now we can calculate, okay, how long, because we know the die is at a uniform temperature and we know the cell temperature, we can figure out how to get it to the target temperature. And the cycle starts at the pre-programmed start time, and basically it gets the die and the oven to the target temperature. So what it is the cycle is a little bit longer. Now we don't recommend using deferred heating cycle if your cycle is going to be, if your off time is less than 6 hours, then there's no point. And another thing is if the cavity temperature is already higher, let's say it's already at 860 Fahrenheit, well, the cycle is not going to start. What we're saying is the oven, so basically we're taking the air temperature of the cavity and saying, okay, this is the temperature of the die. If the cavity temperature is already too high, the cycle does not execute. It will just turn on the cell and go into soaking. All the trends are logged. So all the, basically we're logging every 5 minutes to a database. So you could go back in time and see, all your cell temperatures. So this is showing you the real-time trend, and you can also do historical trend right from the database. You can select whichever cell you want to look at to do any troubleshooting, or want to see, go back and even months if you wanted to. Here's the VOS side of the master controller, where all the data is saved, all the events are saved. So when the die was loaded in the oven, when the cycle was started, how long the die sat in the oven, were there any alarms, things like that. Basically, what you would do is you would select your time window and you click the display report and it'll give you a report. Here, basically, the report is logging which cell was used to heat up the die, uh, what was the cell temperature when you unloaded the die, when the die was unloaded, the time to temperature for that particular die, time in oven, soaking time, how long the die sat in the oven for after the end of the cycle. Were there any alarms, like the oxidization alarm, like after 6 hours we give alarm saying, okay, the die has been sitting in there for too long at higher temperature. Uh, when was the die unloaded? When did we get the first push signal from the press? So we can basically track when the die was unloaded and when the pressure in the press went over 1000 psi. So we can track the time difference and give you uh, the basically the idle time when the die sat in open air, just losing heat. So you could use that as a benchmark and see, okay, it's should be 2 minutes or 5 minutes. If the die was too cold, then we give you an alarm for that. Um, the die unload to press time is logged. If the cycle was incomplete and the operator unloaded the die, we have an alarm for that as well. And we can even track who the operator was. You can filter the reporting by a particular die as well. So if you just want to see a history of a particular die, you can just filter that. So you basically select the die and you press here, there's a button called display die report, and it'll just give you that. Here you were showing you a graph of all the dies, the graph of die to the press, the transfer times. So you have this yellow line here. We can see that some of the dies took way too long to be unloaded and then loaded in. So, you could see that these dies could be, they could cause some problems. And here you have information on each die, the die number and the copy number and stuff like that. So we display it right on the graph. Here is a graph showing you dies, the soaking time. So at the end of the cycle, how long the die sat in the cell for at temperature. So if it's over 6 hours, displayed with this red line, it's showing you like this die sat in there for too long. And so it's basically a very good troubleshooting feature for the production manager. Each heating curve can also be plotted, so you could go back in time and say, okay, I want to see a heating cycle for a particular die copy in a certain cell. So you could go to the report and just click display temp graph, and it'll give you this curve for each heating cycle. This is showing you basically how to manage the data being saved. So you could go 1 month, 6 months, stuff like that. You can purge the data if you wanted to. We also have a feature of sleep or suspend mode. Basically, you go to the screen, you press the suspend button, and the oven goes into the sleep. It's useful if you want to basically shut one cell off. So you have multiple cells. You have 2 cells, 3 cells, right? And you just want to turn one cell off for whatever reason. You can do that by just pressing suspend, so that oven cell just goes into the sleep, so there's no power being used. The lid control options, you have the centralized lid control using the master controller. This is the two-hand anti-tie down approach. We could have even controllers right on the ovens if you don't want to use the buttons centrally. You have the foot pedal control, and you have the hand lever control. So it is totally customizable. So here's I'm showing you a screenshot of an oven with foot pedals. So you have a master controller, but there are no buttons here to open and close the lids. And you open and close the lids right from the oven itself using foot pedals, but still is a master controller setup. So if using centralized lid control, you would go select lid open or close mode, and then you would press the 2 buttons, and you would open or close the lid. Lid safety, there's a lock pin behind each oven. So let's say you want to service the oven and the lid is open, you want to lock it, there's a lock pin available. There's a check valve on each cylinder to lock the lid in place in case of sudden air loss, so the lid never drops on anybody and hurts people. There's a manual release valve. I'll show you in another slide where you can press that and release the air pressure and open and close the lid if you don't have any air pressure available. The power to the heating elements is shut off when the lid is in open position. So we're always monitoring that. There's a sensor on each cylinder. And there are flow control valves on the cylinders to adjust the speed of open and close. We can offer electric actuators instead of the pneumatic ones for the lid open and close. We prefer to go with pneumatics rather than the electric. The pneumatics gives the maintenance staff, gives more freedom. So let's say you want to service an oven, and now let's say the oven is 400 volts. So if it was electric, you would have to take that oven, let's say you're moving it to the maintenance area to do any change elements or something like that. You would have to open and close, you would have to go to the maintenance area and give it power to open and close the lid. But if the lid was pneumatic controlled, you could just connect air. So you don't need to give it 400 volts. Sometimes it's not readily available. So we prefer to go with pneumatics, and it has less parts. We find it's less problematic in the long run. Here's a setup we're showing you for the pneumatic circuit. You have the manual override here. You can press that to open and close the lid. You have the flow control valve. There's a solenoid here to open and close the lid. It's close center. And we run high temp tubing, which is running under the oven. Depends on the application. And you have the limit switches for open and close. And there's a check valve circuit. So basically, in case of air loss, the lid locks in place. These are the mechanical upgrades we have done. So, you have the lid, which is a lot thicker now. Obviously, all around our insulation is around 6 inches rather than 4 inches. You have a steel plate for the lid, so it takes an impact. Then you have your gasket, which is double looped, so it lasts longer. It gives you better sealing. And then the lid has been offset back a few inches as well, so you have more space for loading a die into the cell without hitting the lid. Here are the few upgrades. So here I'm showing you a steel plate on the left hand side for taking some impact, not heavy duty impact, but it will take some impact. And then you have this gasket, which has it's easily replaceable now, the way we've done the design. Before it used to be tucked in, and so we would actually have to remove the liner to replace the gasket, but that's not the case now. Here are our thermocouples. You have so because you have two zones, so this is one zone, so you have a thermocouple running on this side, and then you have a thermocouple running on the side elements, and then you have a high limit thermocouple for each cell. So it's about three thermocouples per cell. To replace an element, what you do is you would take these cotter rings off. So you remove this guard, which is removable, and then you would remove these cotter pins. So there are no real screws to be removed. You just remove some pins, and then it's easy to replace a heating element if you wanted to. Because over time, with high temperatures, the screws do fail. So this is why we have this cotter pin approach. The alarms on the ovens, you have the soak time alarm, you have the over temp alarm, circuit breaker trip alarm, lid open alarm, thermocouple open alarm. So basically all of these alarms are per cell or per oven, and you get the messages right on your main screen. So overall, I would say most of the time you would see just one alarm on our ovens, which would be the soak time alarm when the operators are leaving the die in the oven for too long. I think preset is about 6 hours, so you can adjust that too. But if you leave the die in for over 6 hours, you get that soak time alarm. So you would see some red lights. So here's a view of the alarms page per cell. We are embedding all the schematic and manuals into the master control itself. So here we're showing you like basically PDF files. So it's the schematics for the ovens, the master controller, the operation manual, everything is being embedded right into, so you're not really looking for schematics, they're right there. There's some concern that we've seen where some plants are going away from the RCF, basically because it's been classified as a category 2 carcinogen. We offer alternative insulation made of AES, which is a lot safer. It's environmentally friendly. You can contact Castool for that. CE declaration. I just wanted to point out that CE declaration is there's a number plate right behind the ovens. There's a serial number plate, and there's a CE mark right there on our number plates. We do provide the CE declaration of conformity as needed. We meet all the European standards. This is showing you a CSA or an inspection report for the North American. Well, actually, every single oven which goes out there gets this done. So we have a third-party inspector come in to check each one of our ovens and provide certification. We calibrate each oven. You can calibrate per thermocouple or per oven cavity. You can create an offset. So our software gives a very user-friendly interface of calibration because a lot of plants do hire these third-party companies to come in and calibrate the equipment, I think once a year or something like that, according to whatever standards they've set up. So it is possible to do calibration right on our master controllers. So here's a screen showing you how to calibrate a thermocouple. And here we're showing you how to calibrate just the cell. One thing I wanted to point out was when you're data logging a die, each one of these components used for data logging, there's a tolerance to them. The data logger, the thermocouple, the extension wires. What it is when you're data logging, you have to keep in mind these tolerances because they compile. You know, you can have the thermocouple wire has a tolerance of plus or minus 2 degrees. Data logger has 0.7 degrees. It depends. So all of these tolerances do compile up. So when you're running a data log, you have to keep that in mind. And also the thermocouples, let's say you're running, putting thermocouples in a die and running tests. After a while, you would see drift on the thermocouples, so they do go out of tolerance. So you got to keep that in mind. And we do provide certificate of calibration if you hire Castool to come do the calibration on all the ovens. You can also, this is just slide showing you if you want to do any updates on the ovens, we can load the oven program in a downloader, something like that. We can ship it to you and you can plug it into the PLC and update the program. For the HMI, you can basically you do it through a USB stick. Here's the light stack operation. You have the 3 lights, green, yellow, and red. I think everybody is pretty much familiar with how they work. Yellow is for the cycle on time. Green is basically it's everything is okay kind of thing, is holding temperature. Red is for any alarms. We do offer 2 different types of stack lights. One is the 3-tier, the standard one. One is basically a programmable light. So here we could do a fill. So our operator can see it from far and see, okay, how long the cycle is going to be on for. So, when you start a cycle, it's totally filled with yellow, and as the cycle runs, it gets less and less and less, and then at the end, it fills up with green, saying green and yellow, saying the die is at temperature. So visually, this is better. It's a little bit more cost-wise, a little bit more, but we do offer this option. So you could customize the oven. You can give us your custom die sizes or cradles. We can build them. We can customize as per the PLC brand that you want to use. Same thing with the HMI. You can tell us we want to have this particular size of the HMI or stuff like that, not Castool standard, and we will comply to the request. Networking, you can give us your static IP addressing, so we can pre-program our ovens to have the same networking. Lid control wise, like I've given the options before, you can have centralized lid control. You have two-hand anti-tie down right on the ovens, or you could have foot pedal control, or even hand lever. You could do the different type of stack lights, different type of actuators, pneumatic or electric. We could even do nitrogen piping if you want to have nitrogen in each cell. You could have power meters to track energy usage per cell or per oven, as whatever you wish. And we could do multiple languages. And we could paint the color to whatever suits your needs, kind of thing. But it does take a little bit longer to build the ovens, but we can customize the ovens to the customer needs. Here's the picture of a power meter. Where we're showing you what it looks like, and it can track all the energy usage. So some plants are really into that. We can put remote VPN modules in our master controller, so we can remotely, if you connect us to the internet, we can remotely update programs and help troubleshoot. And for commissioning, we can basically, we recommend whenever you buy ovens, you'll schedule with us. We'll send a technician out, and we'll come over and we'll train the maintenance staff and the operators how to use the ovens properly. And we also recommend doing a maintenance contract with Castool, where we can help with the yearly audits and the calibration and any program modifications, stuff like that. We recommend carrying spare parts whenever you buy oven line for a press. At least get some spare heating elements, at least one set. Get some thermocouples and some solid state relays. That's what we use for pulsing the heat. Oven outside temperatures, I want to touch upon that. We guarantee the temperature of the ovens to be ambient plus 35 degrees Celsius. That's the target that we go with. Generally, they're around 45 degrees Celsius. Some points, let's say right where the lid opens, could be a little bit higher, but that is what we target. So all the ovens are run at Castool for 24 hours. We put dies in, we run a data log, we calibrate each cell, and we do outgoing inspection reports. QPS inspection is done by third party. Here are some examples of inspection reports we do. We do have RFQ sheets. They help us quote you the correct controllers and the ovens. And also there are more customization features available. Just contact us and we can get into more details. And the warranty, ovens are basically warranted for 1 year. The heating elements is 2 years, unless they're getting hit by dies and stuff like that. The lifespan is quite good for our ovens. That brings me to the end of my presentation. Thank you for attending. If anybody has any questions, you can use the chat window and message me, or you can always email me at sales@castool.com, and I'll try my best to get back to you in a timely manner. Thank you very much. Have a good day.